Okay, what is a Taylor approximation of this guy? In general, right? If we are given a function f of x, we can approximate it as a Taylor series function, which is a sum from I is equal to 0, right, to infinity of the derivative of that, the I derivative of that at the point A, right? If it is centered at A, and what else? Yes. Oh yeah, let us write and use the n notation. Okay. Will be n factorial times what? Yes, x minus a to the n. So, or when we write it, when n is equal to 0, it will be the zero derivative, or it means the function f at a, right? And definition 0 factorial is simply 1. And here, the first term, anything to the 0 will be 1, right? So that is why the first term is f of a. The second term, what is it? It means when n is equal to 1. What is it? Yeah, f prime at the point we're looking at times divided by 1 factorial here, x to the a, x minus a to the 1. And when n is equal to 2, it is the second derivative of that function here, right? So, etc. Okay? So here, now we're given that the function f of x is the sine function. And the center A here is at pi over 3, which means this guy we're given. And the function is given. Therefore, we can find the evaluation of this, right, at that point, as well as the first derivative, the second derivative, etc. Okay? So, we know what to do, right? Now, let us find the general forms of the derivative of this first. Okay? Now, it is easier if we take a table to find the derivative. First, we're given the function is sine of x, right? So therefore, what is the first derivative of this guy? Very good. Having the first derivative, we can compute the second derivative here, right? It means the derivative of the first derivative, which is this guy, right? And what is it? Very good. Thank you. So what is the third derivative? The derivative of this guy, it will be negative cosine, right? So now, do not just. I think we should write 4 elements. Yeah. I will state it clearly in the exams, but for now, let us play with 4 elements and up to the 4th order of this is good already. The 4th derivative of the function f of x will be the derivative of this guy, which will be very good. So that is the general forms of these, right? And our job here is to evaluate the values here. At this point, a is equal to pi over 3. Therefore, we need to find that f at pi over 3, which is sine of pi over 3 here, right? For those who don't remember these properties, let us draw a special triangle, right? Pi over 3 is a 60-degree, right? And remember, if this is 2, this is 1, this will be square root of 2 squared minus 1, which is square root of 3. This is the angle pi over 3. So sine of pi over 3, it will be square root of 3 over 2, right? Sine is the opposite divided by the hypotenuse here. Okay, very good, which will be square root of 3 over 2. The second things, okay, now we need to find the f prime at pi over 3, which is cosine of pi over 3. And what is it? 1/2, right? Thank you. And here, f second derivative of the function at pi over 3, which is negative sine of pi over 3. And sine of pi over 3 will be this guy, therefore, it will be very good. And the third derivative here will be negative cosine of pi over 3. And cosine pi over 3 will be this guy, therefore it will be negative 1/2, right? Here, the fourth derivative of the function at pi over 3, it will be sine of pi over 3, which is square root of 2 over 3. Very good. Now we know all these guys, right? We can substitute back to the formula right here. Therefore, the Taylor approximation at a is equal to pi over 3 is now okay, this guy, then we substitute the values of these guys. Okay, f of a, which is f of this guy's square root. Now, before we do this, let us write it as f of pi over 3 plus f prime of pi over 3 x minus pi over 3 plus f second at pi over 3 times x minus pi over 3 squared, right? And let us compute some more terms, which is f, the third derivative of this function at pi over 3 times, oh wait, what do I miss here? Yeah, the factorials, yeah. Remember, it should be, yeah. One over 2 factorials here. One over 3 factorials here. And let us continue. Here it will be x minus pi over 3 cubed, right? Plus the next term, it will be x minus pi over 3 to the fourth. And remember, we should not stop here. Let us just plus so many other terms, okay? Now, we substitute the value we found above to this one. First, f at pi over 3, as we know, that is square root of 3 over 2. Here, f prime at pi over 3, it will be 1/2, right? Times this linear term. What is next? Help me, please. Thank you. This is this guy, right? Multiply x minus pi over 3 here, square. And what is next? Negative 1/2. Remember, this is a product, so you should write it in within a bracket, parenthesis right here. Otherwise, the reader will confuse, and you may confuse yourself. Okay, and we got mistake if we don't write this parenthesis properly. Cube, and the fourth terms, it will be here. What is it? Yep, square root of 3 over 2 times x minus pi over 3 here to the fourth plus etc. Okay. If we are asked, okay, approximate this Taylor function up to the fourth order, then you can write t fourth of x will be simply this guy, right? That is enough, right? Okay, that's it. Anything else? Do we need to clarify here? Yes. You don't have to simplify your answer. Then this should be the one. If we ask in the general forms, it should be this and plus etc. But if we ask the fourth orders of this, then it will be this guy. We stop here. We call it the fourth degree approximation because the highest degree is the number 4 right here. Okay. Is it clear? And I saw many people got mistake in the factorials term here. Remember, the definition n factorials is defined as the product of 1 times 2 times 3 times 4 times etc. until n. Before it reach n, it should reach n minus 1 first, and then n, for example. Therefore, if 9 factorials, yes, right, we can write explicitly here, or we can write that it would be 8 factorials times what? It would be 8 factorials times 9. Or we can write 7 factorials times 8 times 9. It's up to us. Therefore, in abstract forms, n plus 2 factorials here, it would be 1 times 2 times 3, etc. until n. The next letter, integer of n will be n plus 1. Very good. And the next one, n plus 2, right? All these guys from 1 to n here, we can write it as n factorials. Then remember, there is this guy, n plus 1, and n plus 2 right here. So don't miss it. Okay. So therefore, n plus 1 factorials, if we divide this by n plus 2 factorials, what do we have? Let us write this n plus 2 factorials here is n plus 1 factorials times, what is next? Yeah. Then having this, both numerator and denominator has n plus 1 factorials. Therefore, we can cancel out, which give us 1 over n plus 2. Okay. For these general forms, if you don't remember, you can do the similar things as I was doing right here. Write some specific example, play with that. You understand it better. For anything in math, memorize a simple case and play with that. Make fun with that. Okay.